Alrighty, so we are dealing with this situation. You know that 3 is a 0 of the function y equals 2x cubed plus 19x squared minus 12x minus 189. Graphing calculator is out of batteries, so you need to find the other roots by yourself. Well, if we think about how to find the roots, one of the options would be for us to factor our polynomial. And once we find the factors, using each factor, we can find which x values will give us a 0 or root of our function. Because it's going to be very hard to factor this straight up, we need to use the key fact they give us, which is that 3 is a 0. What does that mean? Well, that means that our function can be written in terms of x minus 3 times some other polynomial. Because if x minus 3 is a function, that means when I plug in 3, I must end up getting 0. So knowing that, if we divide our polynomial by x minus 3, well then whatever we get back out is going to be what we need to multiply x minus 3 by to get our polynomial. So with that in mind, let's go ahead and set up our division. 2x cubed plus 19x squared minus 12x minus 189. And we're dividing by x minus 3. So first thing that we want to think about is, okay, if we're dividing a polynomial in, that means when we multiply it, right, imagine this, we're multiplying these two polynomials, we know that this x term is going to be multiplied by the biggest x term in this polynomial, and it's going to need to equal 2x cubed. So the question we ask ourselves is, how many times will x go into 2x cubed, so that when we put it back into our polynomial here, we will be able to multiply it by that particular term and get back 2x cubed. That's where this whole division algorithm comes from. And we just want to remind ourselves that that's how it works. So x goes into 2x cubed 2x squared times, and then just like our regular division, we will multiply our quotient by our divisor. We will get 2x cubed minus 6x squared, and then we're going to subtract, and when I subtract, I'm going to subtract the whole thing, which means that this will become a negative, this will become a positive. And so now I'm going to get rid of 2x cubed, and all I'm going to have left over is 25x squareds minus 12x's minus 189. And I'm going to keep on continuing, right? What I know is, since x times this biggest term is going to give me 2x cubed, well, x times the next biggest term is going to have to give me 19x squared. Okay, but realize that when x is multiplied, when negative 3 is multiplied by our 2x squared, we are going to get a 6x squared, which means we're really looking for 25x squared. Alright, so now let's think about x will go into 25x squared, 25x times, multiply out, and we get 25x squared minus 75x, and we will continue to subtract and end up with 63x minus 189. And now we better end up with no remainder, because if we end up with a remainder, then we will know this is not a factor, right? Because a factor has to go in evenly, knowing that it will be multiplied by whatever our quotient is to get our big polynomial back. So x will go into 63x 63 times. I should probably use the same color here. And lucky for us, this will work out. 63x, and 63 times 3 is going to be minus 189. And so when we subtract, everything will go away, and we'll be left with our new polynomial. So the polynomial that we can multiply x minus 3 by to get our original polynomial back is going to be 2x squared plus 25x. I'll have to squeeze it in here, plus 63. Alright. And that's all great, but what you're probably asking is, well, you should ask yourself right now, what is the question that remains? Have I answered my question? Have I found the other roots? And the answer is not quite yet, because you don't know what x value will make this 0. You don't have, this is a quadratic. It's much easier to find what will make a linear factor 0, right? We know this will be made 0 when x is 3. It's harder to figure out what will make that 0. In fact, we could factor it into two linear terms, since it's a quadratic, and that would tell us the two roots. Now, maybe you want to do that, maybe you don't. And when we get complex quadratics, sometimes factoring is not our best option. So I want you to pause the video right now and think, what could you do in order to find the roots or factors of that quadratic? Right, hopefully in your thinking you realized, hey, I want to figure out what x value makes this quadratic 0. And if you did, then you should arrive at, well, if I'm setting that equal to 0, then I know I can solve it using the quadratic formula. So we'll put this to the side, and what I'm thinking about, I'm taking this quadratic, and I want to know when it will equal 0. 2x squared plus 25x plus 63 equals 0. When will that occur? And my quadratic formula tells me that the x value will be negative 25 plus or minus the square root 25 squared minus 4 times 2 times 63 all over 4. And then the two values that you get will be your roots. So let's call one r and one s. These are just numbers here. And these are the two roots. So now I know all three roots of my polynomial. So I could rewrite my polynomial as x minus 3 times x minus whatever r is times x minus whatever s is. So your goal, your task now is to find the remaining roots, and then you will have your polynomial. Alrighty, hope this helped. See you tomorrow.